isn't going to be a lot of new stuff. There's going to be a few nuggets here and there of stuff that we didn't really cover in Algebra 2. One of them is going to be inequalities, the domain, really focusing on the domain of an inequality, what x values work, and graphing it on a number line. And a lot of that we can do with a graphing calculator. It can show us it there, and we can apply it or use something I call test points, points that work. Yes? You're welcome. And what we're looking at first is quadratics. We talked some with last chapter with quadratics. We talked a good bit in Algebra 2 about quadratics. But kind of graphing a quadratic, writing it in vertex form, and applying some of the properties. Now, basic quadratic function. It has a vertex, which is going to be the highest or lowest point, the maximum or minimum point. It's either going to open up or it's going to open down. And we also have something called the axis of symmetry. The axis of symmetry is going to be x equals h. We can call it h if we're talking about vertex form. It's just the x value of the vertex. It's the line that cuts the parabola in half, where we have a mirror image on either side. And again, none of this is new. So all this here is included in your notes. A function defined by f of x equals ax squared plus bx plus c, where a is different than 0 is called a quadratic function. The reason we have to include the different from 0 is because if a is 0, the ax squared term is gone, it's 0, just leaving us with bx plus c. And bx plus c is just the equation of a line. We need that square term for it to be considered a quadratic. So this is kind of a side note. The ax squared is what we call the quadratic term. Bx is what we call the linear term. And c is called the constant term. It's just a side note. We don't necessarily need that, but that is what we would consider those. We consider it to be in vertex form if it's in the form of a times x minus h squared plus k. The graph of f is a parabola with a vertex of h comma k. It's the highest or lowest point, our maximum or minimum point. So in ALEX, especially when it talks about the maximum or minimum value, we're talking just about the y. For all the ones we're going to look at, we're talking about y. What is the highest or lowest y value that we will have? It's going to be considered a maximum if it opens down, because that's the highest point on the graph we can go. There are no y values going to be bigger than this point. It's going to be considered a minimum if it opens up, because there are no lower points beyond that we can reach. And for quadratics, we have an kind of a maximum and minimum value, a actual maximum minimum. In some of our other higher order functions where we have cubics, because we've seen that those go in two different directions, they have local maximums and local minimums, not the absolute, but in over a certain range. If a is greater than 0, it opens upwards. Therefore, it has a minimum. If a is less than 0, it opens downward. It has a maximum. And the axis of symmetry is x is equal to h, or the vertical line passing through the vertex. So if we look at this here, determine whether the graph of the parabola opens up or down. Well, what would we say? What do you guys think? Is it going to open up or is it going to open down? Down, because a is what? -2, yes? A is negative. That means it's going to open down. It's going to open downwards, which means this is going to have a maximum value. If it opens down, it's going to have a maximum. Now we want to identify the vertex, the x and y intercept, and sketch the function. Now, again, if we're doing this, especially doing it in this order would be definitely helpful. Now, this here is in vertex form. Our y is equal to a times x minus h squared plus k. And the vertex is the point h comma k. Now, the k value is kind of nice because it's exactly what it looks like. It's outside the parentheses, so it's plus k. Here our function has plus 8, so the y value of the vertex is 8. Inside the parentheses is a little funky because we have x minus 1. Inside the parentheses of the standard equation is x minus h. So the h value would be positive 1. Because whatever h is, inside the parentheses, we really kind of have to flip it to get it. Since it's minus 1 inside the parentheses, it comes out as plus. If it had been plus 1 inside the parentheses, it comes out as minus. Because the standard form is x minus. So to get it to be x plus, the value of h had to be negative. Because the only way we can change a negative sign with addition or subtraction is if we have two negatives. That's the only way. We can subtract a negative to make it positive. That's the only way that works. So that does tell us the vertex is 1, 8. Now we can go about graphing it, especially trying to find the x and y intercepts. We did this especially in the last section, last chapter, because if I want to find the x-intercepts, well, the x-intercepts where it crosses the x-axis where this function is equal to 0. And we could go through this and we could say 0 is equal to negative 2 times x minus 1 squared plus 8. And graph this here and see what those values are. And for y, well, it's the same thing, except now we're plugging in 0 for x and solving this here, yes? Luckily for us, and luckily for y'all, the graphing calculator will do this. So what we can say is y equals, we can clear that out, negative 2 parentheses x minus 1 squared plus 8. This is our function, yes? Well, and if we look at the table, what values of x make the y be 0? Negative 1 and 3. So if we wanted to, so negative 1 and 3 are the 2 points it does cross the x-axis. So the x-intercepts are going to be the point negative 1, 0, and negative 3, 3, 0. And most likely what it asks for the x-intercepts, especially in ALEX, it's just going to want negative 1 and 3. It just wants those 2 points, the x values. If we're actually asking for the point, we want negative 1, 0, 3, 0, because that is the point it intercepts the x-axis. Now, it also did give us the y, because the y-intercept is when x is 0, and that is 6. So 0, 6. Is it likely that we'll have more than one y-intercept for any of these functions? What do y'all think? No, because for it to be a function, we cannot have 2 points that go over the top of each other. Yes, we can't make a horizontal or vertical line. Well, the y-axis is by definition a vertical line. So if it's going to be a function, it can only have one y-intercept. However, we can have multiple x-intercepts. Well, we'll sketch the function here in a minute, but determine the axis of symmetry. And especially in ALEX, I'm definitely if we ask this on the test for the axis of symmetry, I want the equation. And I believe Alex is going to say the equation for the axis of symmetry. And what it's asking for is x equals. We want this vertical line going up and down through the vertex. And our vertex, we said, was 1, 8, yes? The x value is 1, so the axis of symmetry is the line x equals 1. And we can go on and say the maximum value, because the maximum value is the y value of the vertex, which is going to be 8. So if it asks for the maximum value, it just wants the y value. If it asks for the maximum point, it wants the vertex. Questions on any of this here? Now, the reason I did those before sketching is, well, one, we can use the graphing calculator. Because you can type the function in, go second table, plot our points. And again, with a parabola, you need 5. You need the vertex and then 1 point to either side, 2 points to either side, and then plot them. And what's nice is, with that also, get this here, since we do know that this here is the axis of symmetry, that all points are equidistant on either side of it, it means that here at 0, 6 is one distance away from it. If I plug 2 into it, I would get 2, 6. Because again, all points are going to mirror this line. And even if we look at the graphing calculator, at 2, I have a y value of 6. So every point that we go away from that vertex, x-wise, the y value should mirror. Because we have 8, 6, 0. So especially if you're graphing these by hand, as long as I get 2 in one direction, I should know the 2 in the other. And then we graph it. Sketch function. And that brings us to the last spot, domain and range. The domain should be one that for any higher degree polynomial function, you should be able to get it pretty easy every single time. Because any higher degree polynomial function, the domain is all real numbers. The domain is all real numbers. The only times we get functions that don't have a domain of all real numbers is if A, x is inside the square root or an even root, or B, x is in the bottom of a rational expression that can divide by 0. There are some rational functions and some radicals where they won't have some restrictions, but for the most part, those are the only cases where the domain will have a restriction, or in those two. Because if it's a quadratic, domain's always all real numbers, negative infinity to infinity. This is the domain. The range for a quadratic is going to include infinity or negative infinity. It's going to include one or the other. It will never include both for quadratics, but it will include one or the other. So, looking at the function, when we're talking about range values, we're talking about the y values. Since it opens down, it's going to go indefinitely in the negative direction. So the smallest value for the range we can have is negative infinity. If it opens up, we will have positive infinity. And the other value that goes in here is the maximum or minimum value. And this here would be 8. Now I do need to make one adjustment, because is 8 a possible value for this here? Can we get 8 as a y value for the range? Well, yeah, it's the maximum, yes? So it does actually need to be included. Domain If the point's included and we start having restrictions, then we have some differences on parentheses and brackets. But with these here quadratics, you will use parentheses every time because we can't reach infinity or negative infinity. But we can reach the value of 8. Questions on this here? Hopefully, you notice that most of the information on this came straight from the graphing calculator. So even if we look at this here, 3x squared plus 12x plus 5, we could get the vertex, x-intercepts, y-intercepts, the sketch of the function, the axis of symmetry, maximum, minimum value, domain, and range, all from the graphing calculator. 3x squared plus 5x, I think it was minus 12? 12x plus 5. X plus 5. Graph, we have this here. Now the x-intercepts for this one aren't nice, so we'll have to do a little work to get those. And if we look at this here, second table, I am able to find the vertex. As we said, the vertex is the lowest or highest point. Also, the points to the left and right of it are going to mirror each other. And as I look at this here, at the very top, negative 4, 5, negative 3, negative 4, negative 2, negative 7, negative 1, negative 4, 0, 5. We have that mirror. And if I actually scroll up and we put this closer to the middle, go down one, we see that negative 2, negative 7, all the points after it, y values, are the exact same going up and down. So that would be our vertex, and we could go from there. Now, that is helpful, that is handy, but three. Let's actually get it in vertex form. Now, for the most part, we don't do this in Algebra 2. Y'all have the tools to do this. You have the ability to do it. We just don't do it. Because we're going to have to do something that we did with circles. We're going to have to complete the square. Because to have it as a set of parentheses squared means it's a perfect square trinomial. The first thing we'll do with that is factor a 3 out of both 3x squared and 12x, which gives us x squared plus 4x. Now this time, because we're not applying it to both sides, we're just applying it to one side of the equation, we're going to put inside the parentheses plus and a minus. We have to do that because we're not adding it to both sides, but also because of the 3. Because whatever value we plug in with the plus has that 3 scalar attached to it. Now the process is going to be similar. Our c value that we need is going to be b over 2 squared. Well, our value of b is 4. 4 divided by 2 is 2. And 2 squared is 4. So we add 4 and we minus 4. And again, this is just another tricky, not tricky, but just kind of clever way to do this. Because plus 4 minus 4 is still 0. Now before we start factoring, because this here x squared plus 4x plus 4 does factor to a nice perfect square trinomial, we just have this negative 4 left in there. However, we can't just tell it to just move out and just be fine. Because if I move it outside the parentheses, it has to be multiplied with the 3. Because everything inside that parentheses is being multiplied by this 3 if we distribute it back out. Because we're saying 3 times this whole thing. So if I move the negative 4 out, it's not just negative 4, it's negative 4 times 3. And negative 4 times 3 is negative 12. Because we don't want to multiply the whole thing through by 3. We don't want to multiply x squared plus 4x plus 4 by 3. Because if we did, we'd have to factor it back out to get back into vertex form. Any questions on this so far? Now, x squared plus 4x plus 4, we have our x, and whatever's inside the parentheses before we square it is what goes in there with it. Since it was positive 2 before we squared it, we have x plus 2 squared. Negative 12 plus 5 is negative 7. Well, that does prove one of our spots, because we did know, or kind of showed with the graphing calculator, negative 2, negative 7 was the vertex, yes? Well, here we can see plus 2 inside the parentheses of vertex form is our negative 2. Minus 7 does show that the vertex is negative 2, negative 7. It also does help us find the axis of symmetry. X is going to equal negative 2. X equals the x value of the vertex. And since we found the vertex to be negative 2, negative 7, we have it here. So did the function open upwards or downwards? It opened up, yes? So that means we have a minimum value of negative 7. Different color. Now the domain is still going to be negative infinity to infinity. All real numbers. Domain's all real numbers. Domain's always going to be all real numbers for these functions here. Now the range, on the other hand, so the range are the y values. Y values are not going to be all real numbers for quadratics. We're going to have a definite endpoint. Now we said it opened up, yes? So it's going up. The biggest value we can actually have is infinity. And since we have a minimum, we will have a smaller value that we can actually reach. And the smaller value that we have is negative 7. It's our minimum value. So the range is going to go from negative 7 to infinity. So the range, when it opens up, is going from the minimum value to infinity. If it opens down, it's going from negative infinity to the maximum. Questions on any of this here? Now the only other thing we have left is the x and y intercepts. Now out of the two, no matter what it is, whatever the function is, the y-intercept the graphing calculator incidentally will give us every single time, even if it's not a nice number, because it's just set that x equals 0 is going to be one of our points, one of our spots. 0, 5. So the y-intercept is 0, 5, or if it's just asking for the value, is 5. And in standard form, finding the y-intercept is actually one of the easiest points to find. Because if we look at 3x squared plus 12x plus 5, if I plug 0 in for x, 3x squared and 12x both become 0, just leaving us with 5. This constant term will be the y-intercept of any higher degree polynomial function. If it doesn't have a constant term of value by itself, factor an x out of all of them, or factor whatever variable it has attached to it out of all of them, and there's your new, or should be new y-intercept. Well, I take that back. If there is no constant term, everything has a variable, the y-intercept is 0. It doesn't have one. So there is that. Now, to find the x-intercepts, we really just need to solve this, because we set it equal to 0. And if we have it in vertex form, I would use this here. And the reason I say that is because if we have a set of parentheses squared, we're going to get them by themselves, square root both sides, and go from there. So the first thing we can do is add 7 to both sides. Tells us 7 is equal to 3 times x plus 2 squared. Divide both sides by 3. Telling us 7/3 is equal to x plus 2 squared. At this point here, we can square root both sides. Square root and square will cancel, leaving us with x plus 2 by itself. This here, especially if it's wanting exact solutions, in the yellow calculator, you can type it in as the square root of 7 over the square root of 3. And it'll do this here for us. So here we can say the square root of 7 over square root of 3, which is square root of 21 over 3. Don't type it in as the square root of 7 over 3 as a whole. It'll just give it to you as a decimal, or it'll just throw it out. It doesn't like it. The 30xs is temperamental on some things. So if you split it apart, it will give it to you. Now, again, whenever we take the square root of both sides, we have to add the plus or minus. And the last thing we need to do is subtract 2. So the x-intercepts are -2 plus or minus square root of 21 over 3. So the x-intercepts for this function are not nice. They're kind of funky. But that's what they are. Questions on any of this here? Determine the vertex of the parabola by using the vertex form. Determine the x-intercepts, y-intercepts, sketch the graph. Determine the axis of symmetry, maximum, minimum, domain, and range. Again, we can look at the graphing calculator. Negative x squared plus 4x minus 5. Negative x squared plus 4x minus 5. We have this here. And again, just like before, one point that we do get that's nice is the y-intercept. 0, -5. So, okay. That's what I see. First, we can put that in. Y-intercept is 0, -5, or we can just say the value -5. That's going to be the y-intercept. That's where it crosses the y-axis. Where did it cross the x-axis? It didn't. So this is none. With any quadratic equation, no matter where it's placed, as long as it's y equals, we're going to have a y-intercept. We might not always have an x-intercept. Now to find, well, let's state whether the graph opens upwards or downwards. This is downwards. We know it for two reasons. One, the a value is negative. Two, that's what the graph showed us. Yes. Determine the vertex of the parabola by using the vertex form. Yep. I'm going to do this a little bit lower. We can say y is equal to negative x squared plus 4x minus 5. Now, between the two x values, there's not a number, but we still need the x to be positive. So we're going to factor a negative out. So we're going to factor a negative 1 out, which means once we find the value of c, its negative is going to be multiplied by a negative 1. Now c is still going to be our b over 2 squared. In this case, b is negative 4. Negative 4 over 2 squared. Well, negative 4 divided by 2 is negative 2. And negative 2 squared is 4. Questions on how we found c or plugged it back in? Now, we do need to get this 4 back out, which is going to leave us with just x squared minus 4x plus 4. But again, when I move that number out, I've got to multiply it by whatever's in front of the parentheses, which in this case is just negative 1. So negative 1 times negative 4 is going to be plus 4 minus 5. Well, negative 4 plus 5 is negative 1. Inside the parentheses, we're going to have x, and then whatever was inside the parentheses here before we squared it, negative 2. So we have it in vertex form, which tells us the vertex is from here and here. Since it's negative inside, it comes out as positive, and the y stays negative. So the vertex for this is 2, negative 1. Determine the vertex, 2, negative 1. Questions on this so far? But if we look back at the graphing calculator, I didn't put an emphasis on it, but 2, negative 1, if we look at the y values, they do mirror everything from this, yes? So we could have gotten that from there. Determine the axis of symmetry. X is equal to what? 2. The x value of the vertex. The x value of the line goes through the vertex. So x equals that x value. Will this function have a maximum or minimum value? Since it opens down, it's going to have a maximum value. And that maximum value is negative 1. It's just the y value of the vertex. Any questions on any of this here? The domain is negative infinity to infinity. The range. So if we have a maximum value, that means we'll have a highest point that it'll reach. If we have a maximum, the bracket goes on the right, parentheses goes on the left. If it's a minimum, bracket goes on the left, parenthesis goes on the right. Because what we're saying, the lowest spot for this is negative infinity, and the highest is negative 1. And I think at this point, we're pretty good on sketch the graph, because again, graphing calculator, vertex, 2 points at either side. Questions on any of this here? Questions on anything we've done so far today? Now this here is really just a side note to this, because we've done this before. We talked about this when solving quadratics. The discriminant, our b squared minus 4ac. Because if we said this is equal to 0, it means the plus or minus that if this inside the radical is 0, we're adding or subtracting 0, which is just going to give us a value. So if it's 0, we only have one solution. There's only one spot it crosses the x-axis. If it's greater than 0, we are adding or subtracting whatever that value is. Be it a whole number, be it a decimal, whatever it is, we're adding it. So we'll have 2 different values because we're going to add and subtract it. And that's true for both of these if it's greater or less than 0. But if it's less than 0, it's not going to have any x-intercepts because less than 0 means we're taking the square root of a negative number, which is I complex. It's going to be above or below the graph, which on our last graph, it didn't cross it, which tells us the value b squared minus 4ac is going to be less than 0. We have these complex solutions. If it's greater than 0, it's going to cross. It can cross at nice numbers. It can cross at not nice numbers. But it's going to cross twice. Questions on this here? Any questions on any of this so far? We feel pretty good with this here for the most part. I mean, a lot of it's not anything new, but it is a lot of information. There is one last thing I want to point out. I'm not going to focus too much on the word problems because they're not bad. We've hit them already once, and just to get everything in, we're not going to talk about them, unfortunately, is this here. And we looked at the vertex form for both of these. Did the value of A change? The value of A for both of these, the one in front of the parentheses, change? Well, it didn't, right? Because this here, even when we got it in standard form, the value of A is 3. The value of A in vertex form is 3, yes? So this is kind of a cheap step, because y is equal to A times x minus h squared plus k. Here, the value of A is 3, yes? And when we graphed it, we found the vertex of -2, -7, yes? We can say -7. That makes... we can get to the exact same place. Now, this only works really if the vertex is a nice number. Is if the vertex had been -2, -7/2, we can't easily see that, or we could see it and then it kind of works, but actually, let me see here. This -2/3, -7/2. When it hits between the x values, then we're going to have a harder time seeing the vertex. Then we would need to go through the process of finding it. But especially if the vertex is a nice number and we know what A is, that's a little bit of a shortcut to get there. Now, I'm not saying either one of these word problems isn't helpful, especially if you're talking about pens or corrals and you're wanting to maximize area. These are helpful because we can use these formulas here to actually figure out what it is. Because if we want to maximize let's see here, 340 feet of fencing and wants to maximize the area. Well, we know area is what? Length times width is equal to our area. Yes? Well, the perimeter, we're not including the road, but this here would be 2x plus y is equal to 340. And we can use these two formulas here to actually figure out what is going to be the best lengths of the two sides to get us the best area. This area is equal to x times y. And we would substitute these in. Yeah, xy. So here we can say y is equal to negative 2x plus 340. Substitute this in for y, and we would actually find the area, the maximum area, which would be x times negative 2x plus 340. And if we find the vertex of this graph, we actually have the maximum value of the area that we can have with the side lengths given. But that's a side note there.